Hi viewers, here let's consider what we have on board. Express the following complex numbers in polar form. Here we have got two numbers. Number A, 5 plus 5i root of 3. And number B, root of 2 plus I. Okay, now I'm going to solve the first one and we're going to solve the second one and you comment with it in the comment section. Okay, whenever you are asked to express any complex number in polar form, there are three steps that you are going to follow. Okay, here let us have number one. You have to make sure that you find the modulus of the given number. You have to make sure that you find the modulus of a given number. Okay, now, and number two, you have to make sure that you find the argument of a given number. In bracket it is angle theta. Okay, now and number three is just only substitution. Okay, substitution. You have to substitute what you have got as your modulus and what you have got as your argument into a formula of a polar form. Alright, so these are the three steps that you are going to follow whenever you are dealing with a polar form. Okay, now here let us first start solving number one by making a solution. Here let us have a solution. Okay, now what we're going to do first is to find the modulus of this number. Now it is given as z. Okay, here it is going to be root of x squared plus y squared. And this is the formula of modulus. Okay, now what we're going to do next is we just have to substitute 5 in place of x and 5 root of 3 where there is y. Okay, now here let us proceed. Here we're going to have a root of into 5 squared plus into 5 root of 3 squared. Okay, now here we're going to have a root of, what is 5 squared? We're going to have 25. Okay, how about 5 root of 3 squared? I think we're going to have 75. We're going to have 75. Okay, now here we're going to have a 25 plus 75. I think we're going to have 100, right? We're going to have 100. Okay, now how about root of 100? I think we're going to have 10. Okay, it's going to be 10 units. Okay, now this is our modulus. Now let us proceed and find our argument, which is theta. Okay, now this is the formula for finding our argument. Here, theta equal to a tan inverse into y out of x. Okay, now I will try to plug in what we have as y and what we have as x. Here we're going to have tan inverse of, here where there's y, here we have a root of, 5 root of 3. Okay, here it is 5 root of 3. Okay, out of where there's x here, we have 5. Okay, given as 5 as bracket. Now I will try to plug this inside your calculator. I think we're going to have 60. Okay, so our theta are equal to 60 degrees. Okay, now I take a note here. First of all, this number here, it falls under first quadrant. Like for example, here let us have some sketch. Let's have a sketch. So, okay, now this number here, it fall under here, okay? It fall under here. So it fall, if you try to plot here, it fall under a first quadrant. And whenever a number fall under a first quadrant, so this is what you are going to do here. A theta equal to theta, right? Meaning theta, it is the same as theta. So here we have got a theta as 60, so it means a theta, it is going to be remain as 60, right? There's no change, it is going to remain as 60 there, okay? Now, this is our argument or a theta, our theta, okay? Now, so what we have to do next is we just have to substitute. Now, what is the formula of a polar form? Z equal to R into cos theta plus I sine theta. This is the formula of a polar form. So now what we are going to do, we just have to substitute our modulus and our theta into this, okay? This area is stand for a modulus, and this theta inside here, it is this, right? So now what we just have to do is we just have to substitute. Now what is our R? Our R is 10, right? So it is 10 into cos, what is theta, is 60. Right here it is cos 60 plus I sine 60. Now we're done with the question. Please likes, comments, and share. Thank you.